Here's the thing. When people talk about AI's environmental cost, they almost always talk about electricity, power grids, carbon emissions, nuclear plants, solar farms, and yes, that matters. But there's another resource AI depends on, and it's one we're already struggling to manage: water. How does water even factor in? Good question. Because the cloud isn't floating in the sky, it's physical. It's buildings, massive warehouses filled with servers running 24 hours a day. And those machines produce heat, a lot of heat. If you've ever felt your laptop warm up while editing a video, multiply that by tens of thousands of machines stacked floor to ceiling. That heat has to go somewhere, and this is where water enters the picture. Most hyperscale data centers use water-based cooling systems, cooling towers, evaporative systems, liquid cooling loops. Cooling scales with compute, which means water scales with compute. In 2023, Microsoft reported its global water consumption increased by approximately 1.7 billion gallons in a single year, a 34% jump. That's enough to fill roughly 2,500 Olympic swimming pools. Researchers have estimated that generating one AI text responses can consume roughly half a liter of water, depending on the data center location and cooling system used. Then there's semiconductor manufacturing. Advanced chip fabrication plants use ultra-pure water in enormous quantities. Some facilities consume millions of gallons per day. So we're not just talking about water cooling servers. We're talking about water to manufacture chips, water to generate electricity, water to cool infrastructure. Aquifers in parts of India, California, and the Middle East are being depleted faster than they recharge. So when we introduce a rapidly expanding digital infrastructure that depends on water, we're not introducing a new problem. We're intensifying an existing one. Water is local. When a region runs dry, it doesn't matter how advanced its servers are. And once groundwater collapses, once those underground spaces compress, they don't recover. That storage is gone permanently. If hyperscale data centers continue doubling, if AI becomes embedded into search, healthcare, logistics, entertainment, finance, autonomous systems, if global AI compute demand multiplies by 5 or 10, then cooling demand multiplies too, unless we radically change infrastructure design, unless cooling shifts fully to non-evaporative systems, unless facilities relocate exclusively to water-abundant regions. We've built a technology that feels infinite, but it runs on something finite. We built exponential demand on top of linear supply, and linear supply eventually constrains exponential growth.